we talked about solving one-step equations, which was very exciting because now we're in the real stuff. This is the real algebra, right? We're using the properties and the rules that we've learned to actually solve for x, solve for an unknown, right? A variable of some sort. And so each class, we're basically going to be adding complexity to the whole thing, right? One-step equations were very, very simple, right? Fifth to 5. You guys felt pretty confident in those?
Yeah.
Right, okay. So two-step equations are almost as easy. Almost. Right?
Easier.
You'll never guess how many steps they require.
2.
5.
3.
How did you guys...
75 million steps.
Oh, 2. Okay. So, ironically, what we learned yesterday is the foundation of what we're going to do today. Knowing how to do the one steps is exactly what you need to know how to do in order to do the two steps. Because each step is one of these steps. That's it. It's one of these steps, right? So we remember we would subtract 7, right? I would subtract 7, right? What am I doing? Not equals. Subtract 7, and then that gives me x is equal to 3, right?
Yep.
Yes?
Yep.
All right.
Yep.
What would I do here?
You would divide by 5.
Divide by 5.
Yep.
Divide by 5.
Yep.
That gives me the 5's crossed out. That gives me x is equal to 15 divided by 5 is 3.
Yep.
Okay. What would I do here? Multiply
Multiply
times
by reciprocal.
the reciprocal. So I'm going to multiply times 3 over 1. Times 3 over 1 or just 3. So it suddenly gives me x is equal to 12. Right?
Yeah.
Pretty straightforward. Now, with two-step equations, what you'll see is something like this. Instead of what we see here, I'm going to cover this up for a second. I'm going to put a 3 right here. So now we have 3x plus 7 is equal to 10. Okay? 3x plus 7 equals 10. Now you solve it exactly like you solved a one-step. You just pretend it doesn't have that 3 in front of the x for a second, right? What's the first thing you would do with a one-step? Subtract the 7. So even if there's a number in front of the x, that's fine. You still want to get rid of the 7 first. That's the first thing you do, right? Right? Because really what this says is this. X plus x plus x plus 7 equals 10. I'm fine with all the x's on one side. I'm not fine with the number on this side, right? So I've got to subtract the 7 first. So that's the first thing you do, subtract that 7. But now I have 3x equals 3.
Oh.
Oh my gosh! That's another one step, right? It's the same kind as number 2. So what do?
You
Divide by 3. Divide by 3. And suddenly you got x is equal to 1.
Wow.
Whoa.
Wow.
All right, let's do another example of this type. Let's say we have 5x minus
32.
minus 30 is equal to 20. Right? What would I do?
So
Sienna.
subtract 30 from both sides. Add 30. Oh no, sorry, add. Wait, no, yeah, subtract. What? Wait.
All right, so if I do that, I get 5x minus 60 is equal to negative 10. Wait, is that right?
No. You gotta add.
So remember, if this sign says negative, this one
Yeah.
has to be positive. So we'll get rid of that again, right? That's got to be positive. So now I have 5x is what? Equal to 50. Now I'm going to divide by 5. Divide by 5. And you get x is equal to 10. Right? Pretty straightforward, right? Pretty easy. The key is you handle them, you start in the exact same way you would start a one-step. Always subtract the numbers, right? Not the x's, the numbers. Don't worry about that 3 yet. that 3 is connected to the x right now. It's multiplying, right? And we don't want to deal with that first. We want to deal with the add and subtract. In some ways, it's sort of the opposite of PEMDAS, because you think of PEMDAS as you do parentheses, exponents, and then multiply, right? You'd think you do that first, but no, we're not going to do that. To solve this equation, we're actually going to do the adding first, right? Or subtracting in this case, right? All right. I don't think I need to talk about that one, but I do probably need to talk about this one, because this actually is what, in a two-step, you're always going to have one of these to do, right? Almost always, right? Because you're always going to have that number in front of the x, so that's going to bring you to that once you add or subtract your term here. Does that make sense? So this one is part of a two-step. It's a one-step, but it's part of a two-step. This one, though, I could make a two-step out of this. Now, it's interesting. I labeled these 1, 2, 3, 1, 2. Great.
What's that going to be for?
I'm a math teacher, right? What do? I don't know what to do. Okay, whatever. We'll call it 4. All right, this is number 4. I'm going to leave myself a little room. Number 4. What do you mean number 4? Oh, yeah, okay. I thought Jan was ready to solve it, but...
It's 4. The answer's 4.
Okay. So, all right, I'm going to actually talk about this for a second, because this is actually a very interesting type of problem. If I said 2/3 x equals 12. 2/3 x equals 12. Now, I taught you yesterday how to solve this in one step, right?
Yeah.
And in case some of you, so in order to solve this in one step, I would multiply times its reciprocal. Both sides times its reciprocal. Great way to do it. But if any of you are a little, so let's have it quiet, guys. If any of you are a little confused about fractions, there is another way you could do it to turn it into a two-step. And the way you do it is you look at the denominator of the fraction. This is a very, very cool trick. And we're going to go into this in more detail in a future lecture, where they're much more complicated than what you're seeing here. But when you have an equation, my guess is you guys haven't learned this either, but I could be wrong. But my guess is when you have an equation, and this only works when you have an equation. If you have an expression, you cannot do this. It only works when you have equation. Why? Because you can do anything to this side as long as you do the same thing to this side. But when you have an expression, you can't. That rule doesn't apply. There aren't two sides, right? You've only got one side, right? But in one move, you can get rid of all fractions in an equation. One move, right? You can have the most horrific looking equation with all these weird fractions, and in one move, you can have no fractions in your equation. And that move and that trick is to multiply everything. So Jaden, you guys, and Rico, you got to listen, make sure you're paying attention. You got to multiply everything by the denominator. The denominator is 3, right? So when I multiply this 2/3 by 3, am I multiplying times the numerator or times the denominator? Let's think about it. If I multiply 2/3 times 3 over 1, right? I'm technically multiplying, it's in the numerator, right? The 3 is in the numerator. You see that? Okay, so instead of writing it as 3 over 1, this is what I'm going to do. I'm going to put a times 3 right here. You see this? And I'm going to put a times 3 right here. Got to do it to both sides. You with me? Look at this. Suddenly I have 2x is equal to 36. In one move, I converted this to a one-step equation. You see what I'm saying?
Magic.
It's a very easy way to solve these things. If you don't like doing the reciprocal, feel free to just do this. Just put the 3, whatever's in the denominator goes up here. and then it goes after that number, right? Then
So
you
cool.
divide by 2, x is equal to 18. Right? Yes, Spacey.
It seems like the second way to do it besides the reciprocal seems like it's more like
Then the reciprocal?
yeah, because with the reciprocal you just flip it.
In the reciprocal, it's a 1-step.
Yeah.
This is a 2-step. You're totally correct. The reciprocal, if you're comfortable with fractions, the reciprocal is the fastest way. If you're not comfortable with fractions, the reciprocal is not the fastest way. Do you know what I'm saying? And when I do the lecture on equations with lots of fractions, you're going to find you're going to have to use this method, the second method, because it would be really hard to use reciprocals on multiple fractions with multiple denominators. You know what I'm saying? See what I'm saying? But we'll get to that. Don't worry about it. But you're totally right, BC. This is more work, but how many people would say that's a little easier? Right? It's a little easier because you don't have to deal with fractions at all. You immediately get rid of them, and then you deal with your 1-step, right? See what I'm saying? So either way is fine. So that's one way you could do this as a 2-step. That's 4. Now how about, what if I give you 5? What about this? Let's say I gave you 4/5 x. Let me just think for a second. 4/5 x equals, well, actually, let's see. Plus 5 equals 25. All right, so that's definitely a 2-step. It could be a 3-step, depending on how you solve it, right? So what would I do first? 30.
30.
30 what? What's 30? The answer's 30? Are you sure?
No. Yes.
I think you're probably right. Yes.
First, you would subtract 5 from each side.
So I'm going to subtract 5 from each side. Subtract 5 from each side. I now have 4/5 x is equal to 20. Now, which way do you want me to use? Do you want me to use the reciprocal method? Let's do it. So I'm going to multiply both sides by the reciprocal of 4/5. So I'm going to multiply this times 5/4. All right? Multiply this times 5/4. Now, remember what I said. Don't multiply them straight across yet. See if there's something downstairs that goes into something upstairs. Does 4 go into 20?
Yes.
So I know 4 goes into itself once, right?
Yes.
And 4 goes into 20 what? 5 times. So suddenly I have these cross out, right? 4 goes into 4 once, 4 goes into 4 once. 5 goes into 5 once, 5 goes into 5 once. So I have 1x, or just x, is equal to 5 times 5, which is 25.
So it wasn't 30.
I just yelled out 30. I had no idea.
Close enough, right? I mean,
46.
shooting for the moon, you might get to Mars or something, right?
Mars.
Right?
Oh, 25.
So
Whoa.
let's just try a few more of these. Let's try a couple more. We have, okay, 5, 6. We'll just try a couple more, just so that we're sure. 2/3 x minus 8 equals 12. All right. 2/3 x minus 8 equals 12. First thing I do is I add 8 to both sides. Right? Then I have 2/3 x is equal to 20. Now I'm going to use the second method, right? I'm going to turn this 1-step equation into a 2-step by multiplying by the denominator, the way I just showed you a few minutes ago. For those who find that easier. Times 3, because that's a 3 down there, that goes with 3 there, times 3. Suddenly I have the 3's cross out. I have 2x is equal to 60. I divide by 2, x is equal to 30. That's what Jan was talking about. That's the 30. You were just, you're like a prophet or something.
Now I can see the picture.
That's awesome, Jan.
26.
That's awesome. All right, fist to 5. Do you guys understand this? Is it confusing?
One more.
4.
All
right. All right, fist to 5. Guys, listen. Fist to 5 on this style. Just a 5 on this stuff.
Yeah.
All right, so this is the one where it's slightly more complicated. But I think it's good enough. So I think we're going to stop there.
Math is math.